Okay, so the last thing that we need to address with this hypothesis test process is writing our conclusion. So we've got assumptions we've checked, we've written out our hypothesis statement, and we've looked at how to calculate p-values, and now we just need to tie it all together. What's the reader supposed to think after looking at all this evidence and all this calculation? What are they supposed to walk away with? And so in writing a conclusion, there's two parts of our conclusion that we need to consider. In other words, there's two sentences we're going to write. We're going to write one, a statement about whether we rejected or failed to reject the null and why. And then two, we're going to write a statement about what this means in terms of the alternative. Okay, and so our generic fill-in-the-blank sentence is going to look something like this. Since the p-value either is less than or greater than alpha, I reject or fail to reject the null. There is or is not sufficient evidence to suggest that, and then whatever the alternative is. And again, a lot of this is in context, so the HA we're going to write out in particular words. Okay, so let's go back and revisit a previous question and kind of jump through the hoops and kind of make sure that everything's fine. So we have that new flu vaccine that claims to prevent a certain type of flu in 70% of those who are vaccinated. In a test, the vaccinated people are exposed to the flu. The test statistic is negative 1.38. Is this claim too high? Write a hypothesis, calculate the p-value, and write an appropriate conclusion. Okay, so they've actually gone in for us and calculated the z-score. We just have to pick it up from here and continue the rest of the problem. Starting off with our hypothesis statement, which is p is equal to 0.7, and then p is less than 0.7, where p is the true proportion of people who are vaccinated who get the flu. Next, we want to go to our calculator and type in our norm CDF. So we're going to do that. Okay, so with our calculator out, I'm going to go back to distributions, and I'm going to go to norm CDF. In this case, I've got actually, I still wanted that up. Sorry. Let me talk us through this. I've got a z-score of negative 1.38, and I'm testing a lower tail. That less than 0.7, I want to see what the probability of it being less than negative 1.38 is. So that means I want negative infinity on one end, so negative 1 e to the 99. All the way up to negative 1.38. And then I'll hit enter from there. Okay, so that's what our statement looks like. Hit enter, and I get 0.0837. Okay, so is 0.0837 smaller than or larger than our alpha of 0.05, and 0.08 is in fact larger. Okay, in other words, the sample that was calculated would happen about 8% of the time, theoretically, and we said that we're not going to get excited unless it's 5% or less. So this is not a significant sample. We would reject the null on that. Okay, so let me get up the verbiage here. Okay, so since the p-value is greater than alpha, 0.08 being greater than 0.05, I fail to reject the null. There is not sufficient evidence to suggest that the true proportion of vaccinated people who do not get the flu is less than 70%. Okay, so let's go into a little more detail then, because previous examples, the z-score was given for us. Let's actually take a look at what happens if we are the ones that have to calculate that. So the formula for a z-score test statistic is statistic minus parameter divided by standard deviation of statistic. In symbolic form, it's the z equals p hat minus p divided by the standard deviation of the sample that we expect based on that. Okay, so let's go through another example and kind of see how one sets all this up from start to finish. So a company is willing to renew its advertising contract with a local radio station only if the station can prove that more than 20% of the residents of a city have heard the ad and recognizes the company's product. The radio station conducts a random sample of 400 people and finds that 90 have heard the ad and recognize the product. Is this sufficient evidence for the company to renew its contract? Okay, so let's go back through the question again, or let's go through the statement. We've got a company that's saying, look, if you guys are doing a good job as a radio station, then we should be able to find that 20% of the city can claim they've heard the ad. So is 90 out of 400? I mean, that's a large number, but is that significant enough that we can say that, yeah, more than 20% have actually heard it? Okay, so we'll go through our assumptions. First assumption is randomness. Do we see anything in the statement that we know randomness has occurred? Yes, we do. Right there in the middle, it says the radio station conducts a random sample of 400 people. What about sample size? Is 400 large enough to reasonably assume normality? And we got 400 people for our sample, and we expect to see 20%. That's what we're testing the claim against. It's that 20%. So 400 times 0.2 is clearly bigger than 10, and then 400 times 0.8. 1 minus 0.2 is 0.8, so 400 minus 0.8 is clearly bigger. All right, so we kind of get this written out here. And then, is it safe to assume that the entire population of the city is at least 4,000? And I think in a typical city, that's a fairly safe assumption that we're not violating at all. Okay, one quick word of caution, especially when it comes to these proportion problems. We're going to see 2% floating around, and whenever we check to see if our sample is large enough, we always check that based on the null hypothesis. So we expect it to be 20%, and that's what we want to check sample size against, not the actual p-hat that we'll look at in a moment. Okay, so now we've got our assumptions checked, and it seems fairly valid that we maintain our normal model here, so we can go ahead and keep going. Word of caution, if we don't pass the assumptions, if there's some sort of concern, say it and move on. Still do the analysis, don't just stop because the problem violated some condition of some kind. Okay, so our null and alternative, we expect it to be 0.2. We're checking for evidence that it's actually larger than 0.2, and we're defining P to be the true proportion of people who actually heard the ad. Then we need to do our calculation. Calculation is 0.225. Now you're probably thinking, wait, I don't remember seeing that number. That's what happens when we take the 90 divided by the 400. So the 90 who said, yes, I have heard the ad, is where we get that 0.225 minus the 0.2, and then standard deviation of the statistic is the 0.2 times 0.8 over n, and then square root that, and we get a z-score of 1.25. Using our calculator, so we want to do norm CDF of 1.25 out to infinity. We should get a p-value of 0.1 with a stated alpha of 0.05. So is this in fact large enough? Is it statistically significant? And the answer is yes. The p-value is greater than alpha, so we failed to reject the null. There is not sufficient evidence to suggest that the true proportion of people who heard the ad is greater than 0.2. The company will not renew their advertising contract with the radio station. Alright, so let me kind of back up a second and kind of point out what happened. Even though 90 out of 400, that seems like a lot. The idea with the 90, though, it was not large enough. Based on a sample size of 400, there should just be more people out there that actually claim that they heard a radio station, if in fact a random sample would have shown that. So even though the random sample was 20%, it wasn't large enough away from what was expected for it to be significantly statistically significant, especially with a p-value of 0.1. So in other words, they're doing a good job, but they didn't do a good enough of a job to continue the contract.